Welcome to my implementation of the COMP3003 set exercises for machine learning. I'll firstly demonstrate a version of the running code. These values are used later for comparison, but I will talk about them later. So initially I set up each dataset, each cluster in the dataset, with its own mean and standard deviation, clarifying the number of samples per cluster, where this data is then generated using the random and repmap functions and then plotted on a graph as seen here, which demonstrates each cluster's unclustered sets amounts of data. Then I use the data I generated from these into a singular trained data 2x(n) matrix, which is then transposed so that it can be used for the k-means and the JM and the optimal k function. This is the merge dataset just to show a successful merge. Next, I find the optimal number of k. These are the number of k values that it will search through, as well as the number of iterations that each k value will go through. This is in a function at the bottom of the page where it works as the k-means. So for each value of k, it will set up new clusters using that k value. So if k is 1, then we'll only set up one cluster. Then for each iteration, so 100 iterations, I will perform the k-means algorithm, so getting the closest centroid to each data point, calculating the distance, and then storing the average distance of each k value inside performance average, which is then displayed to show the effect of each k. As you can see here, the best k value is 9 as it has the shortest distance. And you can see here on the graph as well. Next, I will talk about my implementation of the k-means. Very similar to the optimal k function, but instead of doing a double for loop, it just does one for loop, which does one iteration of the k-means clustering algorithm, which is seen here. I then evaluate the performance of the k-means function by creating a confusion matrix, which extracts the true positive, false negative, and true negative for each class. From there, I then calculate the mean accuracy, recall, precision, F1 scores, specificity, sensitivity of each cluster, which can show an average of the thing, average of the algorithm, seen here. I then implement the Gaussian mixture model, firstly deciding on the initial parameters and choosing the point that will serve as the starting point for each cluster. And then I run the expectation maximization loop, where the expectation is calculating the probability of each point belonging to each cluster, and then the maximization point updates the parameters of each cluster to mold their shape, their their shape and their location. Then I plot the GM model just to show how different it is. This is confusion matrix for k-means, forgot to show that. And then this is the implementation of the JMM cluster. See the difference. And then I set another confusion matrix, which goes over, seen here, which goes over exactly what I said in k-means, the accuracy, recall, precision, F1 scores, sensitivity, and specificity of each. And these are the helper functions, which were used to calculate the centroids, the distance between a data point and each centroid, the closest centroid to a data point, Gaussian 1D, that was used for another exercise, and Gaussian ND, which is the main function used in the GM model, weighted average, and then that is the best k value. Thank you.